There's a road near my house that cuts straight through a mountain. Before that tunnel was built, you had to drive around the entire mountain, add 45 minutes to your trip, minimum. But now, you just go through. Same destination, fraction of the time. I want you to hold that image in your head, because what we're about to talk about is essentially the same thing, except instead of a mountain, it's the fabric of space and time itself. And instead of a tunnel built by humans, this one might already exist, naturally, woven into the universe. And here's the part that keeps certain physicists up at night. Something might already be using it.
Welcome back. This channel is where we take one question and follow it all the way down until the answers start getting uncomfortable. Today's question is this: what if wormholes are real? Not the Hollywood version, not the swirling blue portal from a sci-fi movie. The real mathematical kind. The kind that comes directly from Einstein's equations. The kind that serious physicists argue about in serious journals. And more importantly, what if we're not the first ones to figure out how to use them? Let's start with what a wormhole actually is. Take a piece of paper and draw a dot on each end. To connect those two dots with a line, you have to draw across the entire page, long way around. But what if you just fold the paper, bring the two dots together? Now the distance between them is basically nothing. That's a wormhole, a fold in space-time that connects 2 points that would otherwise be impossibly far apart. And here's what most people don't realize. This wasn't invented for a movie. Einstein and Nathan Rosen derived this mathematically in 1935. It came directly out of the equations of General Relativity. The math says wormholes can exist. That same math predicted black holes, which we've now photographed. It predicted gravitational waves, which we've now detected. It predicted the bending of light around massive objects, which we've now confirmed. The math has been right about everything else. So why are we so quick to dismiss this one? Now, here's where it gets complicated, and honestly, more interesting. The problem with wormholes isn't whether they can exist. The equations allow them. The problem is keeping them open. A natural wormhole, if one formed, would collapse almost instantly, fractions of a second. Nothing, not even light, could pass through before it snapped shut. To keep a wormhole stable and open, you'd need something called exotic matter, a substance with negative energy density, something that pushes outward against gravity instead of pulling inward. Does exotic matter exist? Actually, maybe. There's something in quantum physics called the Casimir effect. If you take two metal plates and place them extremely close together in a vacuum, closer than atoms, a measurable negative energy appears between them. It has been demonstrated in labs. It is real. It's not enough to hold open a wormhole the size of a galaxy, not even close, but it proves that negative energy is not just a fantasy, it exists in nature. And if it exists at small scales, the question becomes, can it exist at larger ones? Nobody knows. Here's the scenario that certain researchers, serious ones, not conspiracy theorists, have quietly started to consider. We have been detecting signals from space for decades that we cannot explain. Fast radio bursts, incredibly powerful pulses of energy that last milliseconds and come from seemingly random points across the universe. No known natural phenomenon fully explains all of them. Some repeat, some don't. Some come from places where there shouldn't be enough energy to produce them. And here's the simple physics argument that some researchers make. If a wormhole existed and something passed through it, the energy released on the other end would look, from our perspective, almost exactly like a fast radio burst.
I'm not saying that's what they are. I'm saying nobody can rule it out.
And then there's the bigger question, the Fermi Paradox. The universe is 13.8 billion years old. It contains hundreds of billions of galaxies. The conditions for life are not rare. So where is everyone? One answer, one that a growing number of physicists take seriously, is that advanced civilizations don't travel through space the way we imagine. They don't spend thousands of years crossing the void between stars. They fold the paper. A civilization that figured out wormhole travel even 1,000,000 years before us, which is nothing on a cosmic timescale, would have access to the entire universe. Every star, every planet, every galaxy. They wouldn't need to send radio signals we could detect. They wouldn't need to fly through our solar system in ships we could see. They could simply step through, and we would have absolutely no idea.
In 2022, a team of physicists at Harvard, MIT, and Caltech did something extraordinary. They simulated a wormhole, not in space, but on a quantum computer. They created two entangled quantum systems, sent information through what they described as a traversable wormhole, and confirmed it came out the other side. This was not a wormhole in physical space. The physicists were very clear about that.
But what they demonstrated was that the underlying structure of reality at the quantum level behaves exactly as wormhole theory predicts it should. The architecture is there, built into the fabric of everything. Whether nature has assembled that architecture at larger scales somewhere in the universe, whether something out there figured out how to use it before we even knew fire existed, that question is still open. And open questions in physics have a funny habit of eventually getting answered.
So now, wormholes are not science fiction. They come from the same mathematics that predicted black holes, which we've now photographed. They require exotic matter, which we've now demonstrated exists at small scales. The universe is 13.8 billion years old. We have been a technological civilization for roughly 200 years. If wormholes are possible, and the universe has had 13.8 billion years to produce civilizations, the odds that we are the first ones to figure this out are almost zero. Almost. Look up at the sky tonight. Whatever you see up there, or whatever you don't, maybe the more important question isn't whether wormholes are real. Maybe it's whether someone is already on the other side. If this sent your brain somewhere it wasn't expecting to go tonight, that's the whole point. We didn't come here to give you easy answers. We came here to ask the questions nobody is asking out loud. If that's your kind of thing, the like button is right there. One tap, it genuinely changes how many people this reaches. And if you're still not subscribed, think about it this way. Every video on this channel starts with one innocent question, and somehow always ends at something that makes you look at the sky a little differently. Next video is already in the works, and I promise you, it starts somewhere familiar and ends somewhere you did not see coming. Don't miss it.